Hey, welcome to the Memorizing Pharmacology podcast. I'm going to take a little bit of a detour today from our mnemonics in the advanced mnemonics from pharmacology and gastrointestinal system. And what we're going to do is we're going to go over the periodic table and go over the first 20 elements and how to make a Google Doc that you can use and kind of keep. But what I want to do is show you how I make them and how you can create it from memory. So the first thing we'll do is we'll create a table here, and we're going to go across 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we're going to go down 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 9 across and 8 down. Okay. All right. We're going to have to make the font 7. That's the only way that everything will fit. So that we don't have to have any letters and words kind of going around, but it makes it a little bit easier. Let's see if we can't make this a little bit bigger to see on the screen. So there we go. All right. So first thing we're going to do, we're going to kind of put some things here on the side. And I think the easiest thing to do is actually not fill these in yet, so I can kind of explain them. But what we're going to do is we're going to put 4 periods here. So we're going to put period 1, period 2, period 3, and period 4. So the periodic table of elements is because the periods have some similarities. Though, as we'll learn, groups, which are up and down or vertical, are actually tend to be more related. And so when we look at group numbers, we would just go put something like group number in there. And I would go 1, 2, 3, 4, 5, 6, 7, and 8. And then we're going to make a little bit of a change. Instead of 3, it's 13. Instead of 4, it's 14. Instead of 5, it's 15. 6, 16. 7, 17. 8, 18. The reason for this is that since we're doing the first 20 elements, and maybe I'll just even make it more explicit that we're doing the first 20 elements from memory, the kind of table leaf that, during Thanksgiving you can put a little extra piece of a table into a dining room table to make it a little bit longer. You're going to see those transition elements. We're not going to mess with those right now. So that's why the group numbers are 1, 2, 13, 14, 15, 16, 17, and 18. And the way that I like to do it is to start with the numbers. Okay, and then we'll go to the abbreviation, which is a lot easier to remember letters than it is to remember names. Then we'll talk about how some of the endings of the names are the same because of the Latin. And then we'll go into atomic mass, so how much each of them weighs. And I'll show you the first 20 elements trick, which is something that a lot of people like to use. Okay, so let's start with just numbering everything. And I think to make things easier or more familiar, what we'll do is we'll use this center align. Okay, so start there, and we'll start with 1. And this is what's a little bit goofy, is that we're going to put our 2 all the way here under group 18. So group 1 is a 1, group 18 is a 2. Okay, then we go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so it's a little bit goofy, but I think it's a little bit easier if you take a look at the numbers first before you ever mess with any abbreviations or any names of any elements. And so what we'll do is, to make it even more clear, we'll bold the group numbers and the periods so that it's a lot easier for you to see. Okay, so now let's do the abbreviations. So it's H, okay, then HE, okay, then we have LI, BE. And what I'll do is I'll show you a way to remember a bunch of these. And what usually happens is you remember them, but not necessarily the order. And so sometimes it's a little bit tougher to remember that order. And what we'll do is we'll see how some words kind of pop up as you're looking at the periodic table. Na, Mg is 12, 13 is Al, 14 Si, 15 is P for phosphorus, 16 is S for sulfur, 17 Cl for chlorine, 18 Ar for argon. Oops. And then we come down to this last one. 19 is K for potassium and Ca for calcium. Okay. So what I'll do is I'm going to put just a couple of notes here that we can use. And we'll put HH to remind ourselves that the first two elements of the periodic table start with an H, hydrogen and helium. And then it is liberating to know all of the first 20 elements. So Li for lithium, Be for beryllium. You have to know your ABCs, and in many ways the periodic table is like your ABCs. And if you look at this box with aluminum, boron, carbon, and silicon, the first letters are A, B, C, S. And what you usually see is some mnemonic that's going to teach you the first 20, and you have to learn it in order. But you don't have to. You can just say, okay, well, here's a little box, and I see ABCs. Okay. You also see the letters NO for make the word no after boron and carbon for nitrogen and oxygen. Okay. Also see, I know this is not really grammatical, but he near. Okay, so looking at the elements in group 18, which we'll learn later are the noble gases, but he, Near. And then I also think about, I'm a runner, I like doing marathons, so someone who runs, you want to drink a lot of water before the race and make sure you're peeing clear. So P's clear, Clar. Okay. So just some ways to remember some of the elements, abbreviations, and where they are. Some other things that I just kind of notice is that N and M are right next to each other in the alphabet. It's just backward, where the M is second and the N is first. And then the K from kalium, which we'll learn about in a second, and K sound from calcium are right next to each other here too. So really, when you're learning the first 20, it's not just about, okay, hydrogen and helium, lithium, beryllium, boron, carbon, nitrogen, oxygen in a linear fashion, but it's also good to kind of keep it sticky in your head that all of these are where they belong. Okay, so let's move on to the names. Okay, so what I want you to look at are some of the endings, and you're going to notice that when you see helium, the next one, lithium, is very similar, as is beryllium. And then boron and carbon, but we don't say that, we say carbon, are similar as well. Nitrogen, the oxygen, and then the original hydrogen are all very similar. Oops, had a little extra typing there with oxygen. Okay. Fluorine is a halogen, which we'll learn about in a minute, but also is going to match up with chlorine down below it. And then neon, we see that ON ending again. And what you're going to figure out is there are just not a ton of different endings. What we're going to do with sodium is we're going to put just under it natrium, which is where the Na comes from. That's why it's not SO. Magnesium, aluminum, and in some countries you'll still hear aluminium, but we use aluminum in the States. Silicon, and this is where it gets a little bit goofy, where if you had pronounced it silicone, it actually makes a different word. So silicone includes silicon and some other things and some of the medical uses that you have for it. Phosphorus, sulfur, and then chlorine, argon, 18. We'll just move this up a little bit. And then for this potassium, we'll do potassium and kalium. And as you get into your study, especially if you become a healthcare professional, when somebody is low on sodium, We don't say hyposodium-emic, we say hyponatremic. If they have too much sodium, we say hypernatremic. And then with the potassium, it's the same thing. We say hypokalemic, too little potassium, or hyperkalemic, too much potassium. So it's important to know where that Na and K comes from, because you're going to be using it if you get into medical terminology. Okay, so Ca for calcium, and that's all the goofiness there. Next thing you're going to kind of do in the progression is you're going to have to learn how much each of these weigh. And we talk about mass rather than weight, and you're going to hear atomic masses. So there's a neat little trick to knowing it, and this is the first 20 elements trick, that any odd number, which is going to be the numbers that we see right now, are the atomic numbers, or the number of protons in each of these elements. So hydrogen has 1 proton, which is a positively charged item in the middle, or the nucleus of the atom. So the odd is going to be double plus 1. Okay? And then the even is going to just be double. And I'll show you how this works out. So hydrogen, we see double plus 1 would be 1 times 2 is 2, plus 1 makes 3. Okay? 2 is even, so we just double to make 4. Lithium is odd, so double plus 1 is 7. So 3 times 2 is 6, plus 1 is 7. Beryllium is 4, so we make it 8. Boron is 5, so we make it 11. Okay, double plus 1. Carbon, 12. Nitrogen, 14 plus 1, 15. Oxygen, double, 16. Fluorine, 9. Double plus 1, 19. Neon will just go double, 20. Sodium, we're going to actually put this between the sodium and the natrium, just so it's really nice and even, nice and clean. And so we're going to see double plus 1 because it's odd, 23. Magnesium, we're going to have double, 24. Aluminum, double plus 1, 27. Silicon, double, 28. Phosphorus, 15. It's going to be double plus 1, 31. Sulfur, it's going to be double, 32. Chlorine, double plus 1 is going to be 34 plus 1, 35. Argon, double is 36. And then potassium, we'll again put it right between there. So we see double plus 1 is going to be 39, so 38 plus 1. And then calcium is going to be double, 40. Now, not all of those are exactly right. There are 4 that need to be changed because they are exceptions. And so the exceptions are, and I just put H-Ben error, okay, so because it's H, B, E, N, and AR. Those are the 4 that we're going to make exceptions, and those exceptions are going to be 1, 9, 14, and 40. And you see the 1, 9, 1, 4, 4, 0, and hopefully you can remember that. So we recognize that hydrogen we changed from a 3 to a 1. That's actually its correct atomic mass. Beryllium we changed from an 8 to a 9. That's its correct atomic mass. Nitrogen goes from 15 to 14, and argon from 36 to 40. Okay, so those are the exceptions. Then what you're going to be asked to do is you're going to ask to name 4 of the groups. So group 1, group 2, group 17, and group 18. The other groups do have names, but we don't really use them. They're a little bit goofy. But if you put the word names in all caps here, the name of the first group is AM, and the alkali metals. The second group is going to be AEM, alkali earth metals. I'm going to talk a little bit about the metalloid stairs, which is not a group as much as it is recognizing where we separate metals and nonmetals, MS. Then we have the halogens, and then the noble gases. Okay, so we'll put these up. But I just put this here because if you look at names, the word names, AM, AEM, and MS are all part of that. Okay, so let's start with this first group name. And what we can do is we can just kind of put this up here. So group name, and we'll put alkali metals, and then alkaline earth metals, and we're kind of losing everything, so we may have to reduce to maybe 150% here so that we can see everything. I'm going to put the metalloid stairs here because they're going to start here, but generally when you see a periodic table that's colored in with some differences in the different colors, you're going to see stairs with boron and silicon and then some of the other elements that are separating metals on the left from nonmetals on the right. Then we go to halogens, group 17 over here, and then the noble gases are group 18. Okay. All right. Then you're going to talk about bonding. There's going to be ionic and covalent bonding, which you'll talk about. So we'll start with ionic charge, and it's going to be where are the pluses. Okay. So the way to do this is to just go plus, 1 plus 2 plus 3x, then plus minus 3 minus 2 minus 1x. And so I'll show you where that all works out. And again, our goal is more to just have this Google Doc where we can always kind of go back to it. So when we're looking at ionic charge, we see plus 1, plus 2, plus 3, x, don't really mess with that one, minus 3, minus 2, minus 1, x. And we see that, hydrogen, lithium, sodium, and potassium will have the plus 1 charge, magnesium and calcium plus 2, aluminum plus 3, and then nitrogen and phosphorus minus 3, oxygen and sulfur minus 2, chlorine, fluorine minus 1. And just an easy way to remember those. And maybe we'll bold these sections to make it just a little bit, stand out a little bit more. It made it go over. Let me get rid of that ionic and we'll just put charge there. Okay. Next thing you'll be asked to do is know the valence number. So valence number is number of electrons in the outer shell. And what we can do with that, though, is we can make it, so I want to center this. So I'm going to center a line. Okay. We just look at the ones placed in the group number. So the valence of group 1 is 1. The valence of group 2 is 2, 3, 4, 5, 6, 7, and 8. So you can write your note here that valence electrons are in the ones place. Okay. All right. So we've built our periodic table, and what some people like to do is they like to color it in with some different colors, and we can do that. And what I want to do is kind of make the colors at least not too dramatic so that it's still useful to you. Okay, so let's just start coloring this in. And the way to do that on Docs is to take the table options and properties, and then you click down here on color. And what we do is we change the cell background color. So with hydrogen, what I'm going to do is, one of the big things is recognizing that hydrogen is a little bit goofy in that it's going to be over here, okay, and it matches up to carbon, nitrogen, oxygen, fluorine, as well as phosphorus, sulfur, and chlorine. Okay. And I made them two different yellows. I didn't mean to do that. Okay. There we go. All right. And what we can do is we can kind of color this box up here above the carbon, and we'll just color that one in the same color. And yeah, that one's a little bit different. I think we'll use this one. Okay. There. Okay, and we'll recognize this as the reactive nonmetals. Okay. We're going to start from left to right, and so what we can do is we can do the alkali metals here. So we'll just color this in, and maybe we'll use kind of this kind of very light red so we can still read our what we've got there. And let's see if even a little bit lighter, just to make it a little bit easier to read those. Okay, there we go. So those are the alkali metals. And then the alkaline earth metals, maybe we can do a little bit of a purple or a lavender that's going to kind of match up with that. There we go. Okay. Then we've got our metallized stairs, and we can think of stairs being, maybe we'll put a kind of a light gray for these stairs. Okay. All right, and use that same one. Okay, so boron and silicon, these are metalloids or semi-metals. They separate the metals from the non-metals. Aluminum, this is something called a post-transition metal, and maybe we'll just kind of make it green to just make it stand out a little bit. And we can kind of maybe put that one up here. So just make the name post-transition metal will be green. Okay, and maybe what I can do is I can kind of move these around a little bit to make it so that they match up a little bit better with where they lie. So here we go. What I might do is take the metalloid reactive nonmetals, and I'll take this label and I'll move it over here where oxygen is. And there we go. Okay, and we'll take this metalloid stairs and put it over silicon, so that's actually over the section that it should be over. And post-transition metal, then we can move over aluminum so it can be in the right place. All right, so we can now change the colors to make it all work out so it matches up. And this guy should be clear. All right. Okay, so some people learn better with colors, and sometimes that's a little bit easier. And then maybe with the noble gases, we'll do orange, something just a little bit distinct from that yellow over there. Okay. There we go. All right, and I won't mess with the halogens, although fluorine and chlorine are halogens. I don't want to make it reactive nonmetals and the halogens because it gets a little bit goofy here. But what I want to do is just kind of show you in our next section how these are used in medicine. And many of these 20 are used either as elements or something else in medicine. But we're already at 20 minutes, so I'm going to do that in part 2.